Can you all see that?
Yeah.
Okay, very good, thank you. So I'm going to be describing work that the informatics team of the M3C has done to create a published data set of metadata regarding the works that have been produced by the consortium. So the goals of this work were to create a legacy data set, to actually publish it with the DOI so that the metadata of the consortium would live beyond the consortium, and include metadata regarding all investigators and collaborators with deposits in the workbench. For each investigator, publications, data sets, studies, collaborations that they were involved in. And then for each data set and study, all the metabolomic workbench metadata and pointers to the raw data in metabolomic workbench. So if you come across the metadata, you can easily go straight into metabolomic workbench. For each publication of the investigators involved with the metabolomic workbench, include the PubMed metadata and pointers directly to the full source. All the data should be in RDF format, describe that, and that makes it ready for use in social networking, statistical, and web front-end software, such as people metabolomics.info. All the data is open, licensed, and published, and all the data should be regularly updated by Metabolomic Workbench and M3C as it has been over the last 4 years. Resource description framework, for those that are not familiar, is a W3C standard. You represent data as a series of assertions with form, subject, predicate, object, like my published paper. An RDF data set's just a collection of triples, set of rows with 3 columns, subject, predicate, and object. Very simple thing. The data set is served from software called the Triple Store, and it supports a query language called Sparkle. Subjects and predicates are URIs, Uniform Resource Identifiers. And the objects of assertions can either be URIs or literal values. We use ontologies to define the entities that can be represented, such as a person, a paper, a study. And M3C uses 56 predicates to represent the consortium metadata, so it's not particularly complex data, of which 29 of the predicates were pre-existing in other standards, and we are using 27 custom predicates for the consortium data. As an example, the 6 triples shown begin to represent a person and a paper authored by that person. So you have a URI, you have a URI for a predicate that declares the type of the URI. So here we're saying X is a person, where person is from an ontology. And then the next triple says X has a property, has full name, and has the text string, Michael Conlon. Pretty simple. And then we see something referring to something else. X is the author of Y, and Y is a paper, and we start to describe the paper. So this was developed by the W3C and is an international standard for data representation. It's useful for queries, data storage, statistical analysis. Network analysis tools are typically based in RDF because it's very good for graphic data representation and visualization. Now, the consortium metadata currently consists of about 1 million triples. That's not a lot when you think, 100,000 times 10. Not a big set of rows and columns. Just not if it was rows and columns. And you can find the standard online there. The data flow for the data set is pretty simple. Starts with the metabolomic workbench metadata, transforms it using the M3C ontology into RDF. From that RDF, we identify people and go get their PubMed metadata, transform that using the M3C ontology, and produce PubMed RDF. Those 2 sources of RDF are then literally just concatenated together. It's triples or triples. We go to Gravitar to get some photos. We found some other photos, and we do some hand edits, and that produces the triple store. And then the triple store, the 1 million triples, can be used to produce, can be used by Python for social network analysis, is the database that's used to back up the M3C people portal and as a real a live application. We can do Python data analysis off the triple store, and we can archive the triple store as clear text. The software that we use is all very standard software. All the software is open source and freely available. The M3C ontology is in GitHub. It's based on the Vivo ontology, a previous project that we were involved with to represent scholarship. The Apache GenaTDB, so the Apache project has produced a triple store that's freely available. We use Sparkle, a standard for query language for triple stores. We use something called triple pattern fragments from Ruben Verboog, who produced a method for creating very, very fast triple queries. We used it to we developed JavaScript to show the data as web pages. We use RDFlib for any kind of statistical analysis of processing of the triples, and we use NetworkX, a Python library for network visualization. Currently, we're representing 1,700 investigators, 2,200 organizations, about 10,000 pubs. And at the bottom there, you see what a person looks like, what a project looks like, what a study looks like. And the data is available there at Zenodo. We also produce data monthly, and it's available from peoplemetabolmics.info. Thanks.